Okay, once you have that all graphed, okay, what we wrote down yesterday is we wrote down that reflections use a line like a mirror, okay? And so you and the person on the other side of the mirror, when you're looking at a mirror, are the same distance from that mirror. And that's exactly what we're going to use as our idea here. So what we're first going to do is we're going to use the y-axis. So if you need to, you might want to label, these graphs aren't labeled like x and y, but this is our y-axis, right? This is the y line. So that is the line that you are going to reflect, or what we said yesterday, the slang term would be flip. So you are going to flip this shape over this line, okay? Which just means that, again, so you and the person you look at when you look at the mirror are the same distance from the mirror, or to the mirror. So what this means is I'm going to take this E and I'm going to put it in the same distance on the other side. So again, today we are just counting. You just have to know which direction to count. So I'm going to count from E directly to the line. 2, 3. 1, 2, 3. And that is your new E prime. Okay, so I counted from the dot E. 1, 2, 3, over to the line that I'm using for the reflection. Okay, so the line I'm reflecting over is the line, the y-axis. Okay, then we're going to do the F point. So I'm going to take F and I'm going to count until I hit the green line here. So 1, 2, 3, 4, 5, 6. Now we shouldn't be surprised about that because it was 6 away. That's what that number is. So 6. So it counted to 6, and then I'm going to count 6 on the other side. 1, 2, 3, 4, 5, 6. So there's my F prime. Prime just means after, right? The prime is what it would be after the reflection, okay? And then what about D? If D is on the line of reflection, how far do you have to count? Not at all. You don't count. So if you don't count, then you don't move it. So D is actually going to stay right here. So this is also D prime. This is D and D prime. So go ahead and connect them. And it should look like the same shape was flipped over that line. Okay, so that one should be flipped over the y-axis. This time, we're going to flip it over the x-axis. So this should be flipped down. Just going to draw. That's a great question to ask. So the first, can I just write down the coordinates here? When my original DEF was 0, 2, 3, 8, and 6, 5. Okay, so you guys might be counting, but just when I'm done writing the coordinates, we'll look up and we'll see what happened with the coordinates. So that was my original coordinates. My new coordinates were 0, 2. That didn't go anywhere. Okay, so I can't tell anything from that. That's D prime. My new coordinates for E are negative 3, 8. And my new coordinates for F are negative 6, 5. Okay, and this will actually show up on your theorem sheet. So on the theorem sheet, it'll actually have this part written out. But here's the rule for a y-axis reflection. So in rule notation, which we learned yesterday, rule notation, I want you to take every xy and change which part of it. Did you see what changed? Yeah. The x changes to negative. So all I'm going to change when I reflect over the y-axis is I'm going to change the x coordinate. Okay, that's the rule. There it is. It's wonderful to see in all of its beautiful glory. Do you need that rule, or can you just count? You can just count. So that rule is on the theorem sheet. You get that for the test, but do you really need it? No, you don't. So then if I flip it over the other way, though, an x-axis reflection. So a y-axis reflection was there. So the x-axis reflection takes every xy and changes. Okay, so I'll slow down for that part so that we can get that last piece written in. So it takes every xy and changes. What do you think this time? Is it going to change the x or the y? It's going to change the y. So an x-axis reflection will actually change the y to be negative. And a y-axis reflection will make the x be negative, which is information you can use on your homework to make your homework a little bit shorter on a couple of the problems. But again, it's not necessary. You can use it. You can say, wow, that's nice information to know. But it's not necessary. Okay, so I'm going to go ahead and do this one. Okay, so some of you were already counting. Okay, so let's just put this one down here. That would be our D prime. Flipping that over. 1, 2, 3, 4, 5. Count to the line. 1, 2, 3, 4, 5. Here's my F prime. Should be 8. Did you miss one?
No, I wrote the wrong grid. It's fine.
It's okay. Just draw an arrow.
Yeah.
There you go. Okay, so those should be pretty straightforward. Those on your actual homework tonight, super lucky for you. I already put the picture on there, so you just have to do the reflection. Okay. The next one, though, this is the one you're actually going to have to draw the original shape and the new shape. Okay, so these two down here, so you already have the picture of the triangles drawn on there, right? The question is, do you remember what the line y equals 2 looks like? Okay, where is y equals 2? It's right here. And then the line that goes through that y equals 2, where every y value is 2, is this line. So the reason that we're doing this particular problem is that we need to know that every y equals line is a horizontal line going right to left, and every x equals line is a vertical line going up and down. Okay, so we are flipping this triangle over this green line, and then when we go to this one, this x equals -1, we will flip our triangle over a vertical line here at -1. Okay, so we're basically just taking a measurement from one side and then making that same measurement on the other side. So we're basically just making it symmetric on both parts, but we'll get to that idea later. So again, we're just counting this distance, and because it's in the coordinate plane, it's got nice easy boxes. So 1, 2, 3, 1, 2, 3. This is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And once again, that D isn't going to move anywhere. So we've got an F prime, we've got an E prime, and D is going to stay right where it is. Okay. And then same thing. So your brain is going to want to stop when you're counting. Your brain is going to want to stop at this black line because it's a big, thick black line. So if you want to use like a different color to label or draw in your lines like x equals or y equals, that does sometimes help so that you visually can see that a little bit better. So 1, 2, 3, 4 to this line, 1, 2, 3, 4. That's why the green highlighter here did help me see these a little bit better. 6, 7. And do just check to make sure that your shape doesn't look super wonky when you're done. It doesn't have to look perfect, that's for sure. but the coordinates, if you get the coordinates in the wrong, the shapes might not look the same. Okay? Okay, that's it. We've done our reflections. There's no going backwards for the reflections, because if I gave you the reflection and asked you to find the original, you would just be doing the reflection. Okay, so like yesterday, we had the going forward, going backwards problems, which I can help you with right now. There's plenty of time for us to answer questions on those problems from the bottom of yesterday's worksheet if you didn't get those done or have questions on those before you turn that in. Or you can just work on today's worksheet.